The first question is this. So you need to go ahead, and I have given you a sequence, and the sequence that is given to you is an is equal to minus 1 to the power n, where n belongs to natural numbers. You need to go ahead and find range of this sequence. I'm giving you a moment, try to answer this for me, then I will go ahead and I will share the solution with you. So you are given a sequence and you need to go ahead and find the range of this sequence. Take a moment, beta. Okay. So, okay. So you're saying C, fine. Others, just go ahead and try to answer this. So see that domain is what you put in, right? So n belongs to all natural numbers, na? So n belongs to natural numbers. So when I talk about the domain, I know it should be natural numbers. Range is the output you get, the return answer that you get. So beta, when I go ahead and I put n as 1, what will I get? Minus 1 to the power 1, which means minus 1. When I put n as 2, what will I get, beta? Minus 1 to the power 2, which means 1. When I put n as 3, minus 1 to the power 3, minus 1. When I put n as 4, minus 1 to the power 4, 1. So you see, I am only fluctuating between two numbers, minus 1, 1, minus 1, 1, and so on and so forth. So what is the output that I am getting? I am getting just two things in return, minus 1 and 1. So if I were to also go ahead and plot this now, how can I go ahead and show this diagrammatically? I can show this saying something like this, that here, you know, if I put any odd number, 1, 3, 5, 7 and so on, then for all of those, the answer that I get is minus 1. So they all link to minus 1. Right? And for any even number that I put, 2, 4, 6, I just get the answer as 1. So the range is only minus 1 and 1. All of you are correct who are saying the answer to be C. The answer is in fact C. Okay, beta, go to the next question, and the question is this. So you are given that n stands for the set of natural numbers. Which of the following is an unbounded set? Beta, today all questions that I am doing with you are ISI questions. When I come with IIT questions, you will see that the similar kind of question can also come as multiple select question, MSQ question. So more than one answer can be correct for these questions also when it becomes an MSQ question. But for today, it is an MCQ question. So tell me what the answer to this should be. So I am waiting. I am looking into the chat window to try and answer this question. N stands for the set. Remember, a bounded set. But that is one which is both bounded above and bounded below. So when I talk about an unbounded set, let me just zoom this a bit for you. An unbounded set is one which is both bounded above and bounded below. In this case, you have to see which is that set which is either bounded above or below but not both. So just try to think about this. Let me give you an example. Look at option number D here. Look at option number D. What is option number D doing? Now option number D says that x is such that n belongs to natural numbers and x is less than 4, 5, 3, 2. N belongs to natural numbers. Natural numbers start from 1. So it is starting from 1. Matlab 1, 2, 3. And it is ending at 4, 5, 3, 2. So the last natural number can be 4, 5, 3, 1. It is bounded below. The minimum number I have is 1. It is bounded above. The maximum number I have is 4, 5, 3, 1. So there is an infimum to it. There is a supremum to it. This is bounded. Now can you try identifying which is that set which is not bounded, which is an unbounded set? Okay, so you are saying C. That is the correct answer to this question. Why beta? Because when I put n as natural numbers, what will happen? It says x is such that x is 2 to the power n. So beta, when I put n as 1, I will get 2. When I put n can only be natural numbers. So when I put n as 2, it will be 4. Then it will be 2 to the power 3, 2 to the power 4 and so on. There is no upper bound to this. There is a lower bound. It starts from 2. But there is no upper bound to it. So this is unbounded. So that is what we can go ahead and we can say in this case. Let me zoom this a bit for you. So what can we go ahead and say? We can say that Z is bounded below. There is a lower bound to this, but it is not bounded above. There is no upper bound to this. So since there is no upper bound, it becomes an unbounded set. And that's the answer to this question. Okay, beta, come to the next question. Let me zoom this a bit for you. Try to solve this question. Which of the following sequence is a bounded sequence? There are 4 options. You have n, n square, n cube and 1 by n. You have to tell me which of this is a bounded sequence. That means it should be both bounded above and bounded below. Both should be satisfied. So just try to think about it. Okay, so you are saying D. Let others join in. Let's see what the answer should be. What do you think should happen? Try with the first one, beta. N ko, when I put n as 1, I get 1. Then n as 2, I get 2. Then 3, then 4 and so on. There is no upper bound to it. It starts from 1 but it continues. No upper bound. But when I put n square, when I put 1, I get 1. 2 square 4, 3 square 9, 4 square 16 and so on. No upper bound to it. So this is not bounded. Can you tell me what happens with n cube? Yes ma'am. Same will happen with n cube. 1 cube, 2 cube, 3 cube and so on. No upper bound to it. But what about 1 by n? 1 by n is bounded below also and above also. How? Let me start by putting n as 1. When you put n as 2, what will you get? Half. That means 0.5. When you put n as 3, what will you get? 1 by 3, 0.33. Then 1 by 4, 0.25. And so on and so forth. But when you put as n as infinity, anything by infinity is 0. So, it is going towards 0. It means that whatever you put, n की कोई भी value डाल लो, everything will be between 1 and 0. You have the bounds defined. It cannot exceed 1. It cannot be below 0. Everything is between 1 and 0. It becomes both lower and upper bounded. Therefore, it is a bounded set. So, the third part that I get, the answer that I get to this question will be 1 by n. It is bounded. Okay, but I come to the next question. Let me zoom this a bit for you. This is very difficult. Take some time, try to do this yourself. Pretty good question. Okay, beta. It says the following. Consider a mapping F from set of natural numbers m to set of integers. So I am going from natural numbers to integers. And the function is defined in two ways. One, the function is defined as n minus 1 by 2. When is this defined, beta? When it is odd. And it is defined as minus n by 2. When is this defined, beta? When it is even. So function has two parts to it. One when it is odd and second when it is even. I have defined the function like that. You have to go ahead and tell me whether it is 1 to 1 or not, whether it is onto or not, whether it is both, whether it is either. Take some time. This is a tricky one. Try to solve this yourself. Then I will discuss this with you. Take a moment. Write your answers in the chat section. Okay. Let's start. I am going to take the first case, and that case is going to be that, okay, first of all, just try to think about it. First of all, I need to ask if it is 1 to 1 or not. Just think about this. The function, the way that I have defined the function, it says that if you put anything odd in n, you will get a corresponding value attached to it. Anything odd. Like I put n as 1. Then I will get 1 minus 1 by 2. That means I will get 0. When I put n as 3, I will get 3 minus 1 by 2. 2 by 2, that means 1. I put different n's and I will get different functional values attached to it. This is when I am showing when n is odd. Same try for even. I put n as 2, but I will get 2 by 2, which means minus 1. I put n as 4. I get 4 by 2, minus 4 by 2, which means minus 2. So I put different values of n and I am getting different answers. This should hint you something. Now let's see this proof. So I am saying let n1 and n2 be two numbers such that they are odd numbers. Then what can I go ahead and do? Ma'am, let me go ahead and see what happens if I try to equate f of n1 to f of n2. The rule is that if f of n1 equal to f of n2 implies n1 equal to n2, then ma'am it is a one-to-one function. Right? So if the functional values are same and it gives me that those x's were same, the numbers I plugged in were same, it will be a one-to-one function. So just think about this. एक और example लेके देखते हैं before I go ahead. All of you should be aware about this, the mod function. What is my mod function? Mod function looks like this. Here I have two n's, n1, n2, and they give me the same value of the function. One value of function attached to two different values of n, it's not a one-to-one function. A one-to-one function means if the functional value is same, it should imply that my n1 and n2 should also be the same. Let's try this here. So if I try this when my n is odd, so when my n's are odd beta, then what do I get? I will use the function n minus 1 by 2 now. So I took n1 minus 1 by 2 is equal to n2 minus 1 by 2. When you solve this, you will get n1 minus 1 is equal to n2 minus 1. This implies n1 is equal to n2. So I started by equating the function and I got that n1 and n2 are equal to each other. It means it is a one-to-one function. Try it for the even values also. Try it for the even values also. So for even value, what is your function beta? The function is minus n by 2. Let n1 and n2 be both even. So if minus n1 by 2 is equal to minus n2 by 2, so beta 2 and 2 cancels out. Minus minus cancels out. It means n1 is equal to n2. So when my function are equal, I am getting that these numbers are also equal. That means it is a one-to-one function, whether it is even or odd. So we have proved that it is a one-to-one function. Homework for you. You will prove this. That is why I haven't written anything here. You will go ahead and prove to me that it is also an onto function. So it will both be a one-to-one and onto function, and therefore all of you who are saying that the correct answer should be C are correct, that it is both one-to-one and onto. A very good tricky question. Why? Because in this beta we have two parts given to us. Just a hint for you for onto. Beta, f is a function that goes from n to z. Just try to think about this. Okay, I am leaving that to you. Okay, beta, next question. I am giving you a moment. Try to solve this on your own. It says, which of the following is not a bounded sequence? I am waiting for your answer. Try to solve this. It is not bounded, huh? The options given are 1 by n, 1 by n square, 1 by n to the power 3, minus 1 to the power n into n. Which of the following is not a bounded sequence? Try to solve this. Okay, beta? Okay, you're saying B. Let's see. Let me take this with you together. So look at the D part. You're right. But look, simply try to use method of elimination sometimes. Huh? So look here. Minus 1 to the power n into n. Put n is equal to 1. What will you get? Minus 1 to the power 1 into 1. What will you get, beta? Minus 1 into 1 minus 1. That's the first element. Put n is equal to 2. What will you get? Minus 1 to the power 2 into 2. So 1 into 2, so 2. Second element. Put n as 3. Minus 1 to the power 3 into 3 minus 3. So you see that there is no bound. How is your sequence going? If I were to show this graphically, very simple. The numbers I have here, they go, I have minus 1, so minus 1, and then I have plus 2, and then I have minus 3, and then I have plus 4. So you see that this is exploding series. Minus 1 plus 2, minus 3 plus 4. So it will keep going like this. It will become bigger and bigger and bigger. Here also, in the lower part also, and in the upper part also. There will be no bound to it. Right? So, because there will be no bound to it, therefore it will be an unbounded sequence. So everyone who said that the answer should be D, you are correct. The correct answer to this question should be D. And that's absolutely correct.